In this session, we will be looking at kinematic equations. Specifically, by the end of the lesson, you will be able to derive kinematic equations, use kinematic equations in solving problems, and affirm kinematic concepts in solving problems using equations. On the past video, we introduced the concepts of kinematics. We talked about distance, velocity, and acceleration, along with sub-concepts under this, like average velocity, instantaneous speed, gravity, and momentum. And these are the initial equations for these concepts. For velocity and speed, both are equal to displacement over time. Average speed is equal to the sum of instantaneous speed divided by the number of speed variables. And for acceleration, it is equal to the difference of final velocity and initial velocity divided by the time or duration. These are the equations for uniform motion. As we transition from one-dimension motion to two or more dimension, here are the equations for uniformly accelerated motion. For these equations, they don't exactly come from a single concept like velocity or displacement. Rather, these equations were derived from one or more equations. Equation 4 was derived from equation 1 and equation 2, or from velocity and average speed. Equation 5 was derived from equation 3 and equation 4. While equation 6 is the product of equations 1, 2, and 3. Let us apply these equations in problem solving. You may pause or play the video as needed. An airplane accelerates from rest on a runway at 5.5 meters per second square for 20.25 seconds until finally taking off. What is the distance covered by the takeoff? Here's another one. From rest, a jeepney accelerates uniformly over time of 3.25 seconds and covers 15 meters. What is the acceleration of the jeepney? And for the last one, a train accelerates to speed of 20 meters per second over a distance of 150 meters. Determine the acceleration of the train. These are the acceleration for horizontal motion. For vertical motion, it will slightly be different. We only have to replace acceleration with a constant value, g, or the acceleration due to gravity. For example, determine the height of a building if it took 1.5 seconds before a pebble reaches the ground. In the next session, you will use these methods as components for two-dimensional motion. In this session, you learned about derivation of kinematic equations, application of kinetic equations in solving problems, and affirm kinematic concepts in solving problems using equations. That's it for this clip. See you again in the next one.